right, 7-4 notes. First of all, if you have not turned in 7-3 homework, you need to pause the video now and get it turned in to me. All right, direct variation is a special type of linear relationship that can be written in the form of y equals kx. Now, we've talked about direct variation, where k is the constant of variation. When written in this form, we say y varies directly with x. The graph of a direct variation is the line with the following properties. The line passes through the origin, which means y-intercept is 0, 0, and the slope, we use the letter k instead of the letter m. All right, so we're going to determine whether it's direct variation or not. Okay, so we are going to do this. We're going to find the equation of this line. So let's find by doing change in y over change in x. So when we change in y is 6 plus 12 is 18, so 12. Change in x is plus 2, so we get 6. So that is my slope, m equals 6. And then we can pick a point, and we can do y minus y1 equals mx minus x1. So y minus, I'm going to just pick the first point, 6 equals my slope, which is 6x minus x1, which is 1. So y minus 6, distribute 6x minus 6, add 6 to both sides, and I get y equals 6x. So does it have that plus 0? It would be a plus 0, so yes, this is a direct variation. Yes, direct variation. Okay, let's look at another one. We also could have then used this slope. So this would have been a 6. This could simplify to 6 over 1. I just want to show you this. I'm sorry, it's off the thing. Which means that my y is changed by 6. So if I change this by 6, and this doesn't work pretty for every, I guess it could. Someone will take a little more work. So if this is changing by 6, it'd be 0. And my y was changing, and my x was changing by 1. This would be 0, and I could see the 0, 0 in the table. So that's just another way to do it. Sometimes that way the numbers don't work out really pretty, but let's go ahead and look at number 2, and let's find our slope. So change in y over change in x. My y is a big change. It's plus 16. Sorry, I was questioning myself on that. My brain kind of went foggy for a minute. And negative 3 to 1 is plus 4. I'm going to go ahead and put it in the form of 4 over 1, which equals 4. Okay, so now my equation is going to be y equals 4x. So I do have a 1 there. So I'm going to come write it here. So if my x is 1 and my y is 9, my y is going to change by 4, so it's going to go to 5, and my x is going to change by 1, so 0 will be across from 5, so that is not a direct variation, but I can also use the equation, y minus y1 equals x minus x1. So y minus, I'm going to use the 1, 9 so I can stick to using some positives. I just prefer, and I know most of you do better with positives. So plus 9, plus 9. So these are going to cancel. So 4x, and it's going to be plus 5, which I'd already found from doing my table up here. So that is not direct variation. This is easier to see. It doesn't go through the origin, so no. Okay. Does this one go through the origin? Yes. All right, so let's look at a little bit, let's look at number 5. The number of hamburgers that can be made varies directly with the weight of ground beef that is used. Okay, so we have that number of burgers varies directly with the weight, I'm going to put pounds, LB, pounds of beef. So going back to my y varies directly with x. So y varies directly to x. So that gives me my y and my x. So I'm going to make a little table here. X and y, and x is pounds, and y is burgers. Okay, let's say that again, just because I feel like that's a little confusing. The number of hamburgers that can be made, so number of burgers, varies directly with the ground beef that is used, with the weight of ground beef, so pounds of beef. So then I go back and I read that as y varies directly with x. So my x is my beef, my pounds of beef, and my y is my burgers. So when we have 5 burgers for every 2 pounds, write a direct variation equation for the number of burgers y can be made from x pounds of beef. Okay? Then graph that relationship. Okay? So we know it's a direct variation. So I know that I'm going to have 0, 0. So I'm going to put a dot at 0, 0. And my x-axis is going to be pounds. So pounds. So I'm going to label every other. I'm one of those people that I don't like every line labeled. It looks very messy. I'm so sorry. Couldn't pause quick enough. So sorry. And then over here we have burgers. And I'm going to label every other line also. But I'm still going to go by ones. Alright, so I have 0, 0, and then I'm going to have 2 pounds, 5 burgers. So if I had 4 pounds, I'd make 10 burgers. And so there is my graph. Sorry, I don't know where my ruler went. I'll use the index card, or I'll use the, sorry, that's my to-do list, sorry. Sorry, I do a daily to-do list, but it's the nearest thing. Okay, so there's my graph. So my equation is going to be y equals, so my change here is change in y is 10, change in x is 4. So change in y is 10, change in x is 4. 10 divided by 4 is 2.5, so 2.5x. We know it doesn't have a plus after it because it told us it was a direct variation. We have 0, 0, and we see it goes through the origin. All right, let's look at the back. Number 6. Suppose the value of y directly varies with x. Y equals 24, x equals 18. What direct variation equation relates x and y? All right, so let's look at that. Sorry, I keep going off the screen on you. Okay, so our direct variation equation is going to be y equals kx, okay? All right, so let's make a table. X and y. I know it varies directly, so I know it's going to be 0, 0. And then I know that my x is going to be 18, and my y is going to be 24. I get that from my problem. Okay? So what is the value of y when x is 12? Okay, so we're going to have to first figure out our equation. So change in y over change in x. Change in y is 24. Change in x is 18. Okay, this is going to simplify. Let's see, 6 can go into both of those. 4/3, so I'll put 4, y equals 4/3 x. I'm going to leave it as 4/3 instead of changing it to a decimal. And the reason why is because that decimal is repeating, and so it kind of gets pretty ugly. So, all right, so let's look at what would my value if x equals 12. So when I have x equals 12, so my equation, y equals 4/3 times 12. okay, is going to be 16. Okay. What is the value of x when y is negative 8? So when y equals negative 8, so I'm going to plug in, that's my y spot. So negative 8 equals 4/3 x. Okay, we have to do a quick, actually I'm going to work that over here because I didn't leave myself much room. So y equals negative 8. So negative 8 equals 4/3 x. So I need to decide how do I get rid of that 4/3. So I'm going to multiply it times its reciprocal. So 3/4. And so x will equal, is it canceled? -2. -6. -6. Okay. So what I did here is I took that it's a direct variation, which means I have the point 0, 0. I took the other points it gave me and put them down. And then I found my equation. And then I plugged in a x value to find a y value from that equation, and vice versa. All right, let's look at number 7. The mass of a substance varies directly with the volume. So we have mass varies directly with volume. So we say y varies, I'm just put varies directly with my x, okay? And if you forget that, it's okay to look back at that. It took a couple times. Y varies directly at x. It is on the front. Okay, so that kind of helps us a little bit. 80 liters. So I'm going to go ahead and make a chart here. I'm going to put x and y, and this is my volume. This is my mass. Okay, so 80 liters of substance, so that's a volume, has a mass of 100. I also know 0, 0 because it told me it directly varied. Okay, what is the volume? So I want to know what x equals 32 kilograms. So 3.2 kilograms is my mass, which is my y. So I'm going to put y equals 3.2. What's my x going to equal? Okay, so first of all, I need to figure out my equation. So I know it's going to be y equals kx. So find that slope. Change in y is negative 100. Change in x is negative 80, just because I put them in that order. So the negatives actually canceled. And I get 5/4. So y equals 5/4 x. Now, of course, if you find a mistake in me doing this, please call it to my attention. Especially at the end of the day, after a full day of doing math and using my brain, I sometimes make mistakes. So I do apologize if you catch a mistake, but if you do, just call me out on it. It does not hurt my feelings. Okay, so we have 3.2 for my y. So I'm going to multiply times its inverse, which is 4/5. I'm going to use my calculator, and I'm going to do 4/5 times 3.2 to get 2.56. All right, let's look at number 8. The total cost of filling up a car with gas. Okay, so the cost varies directly with the number of gallons. So y is my cost, varies directly with x, my number of gallons. Okay, so I'm going to go ahead and make my table here. And this is gallons. Now, those of you who are prone to silly mistakes, or those that it takes a couple of times to really get down a problem, that is me. And so, therefore, you're going to see I'm labeling everything. I know that there are some people who do this without a table. I know there are some of you who can do this without labeling gallon and cost. Because of the way my brain works, which is perfectly fine, I need to keep everything organized in my work and in my thought process. And so this helps me to avoid silly mistakes. So if that's you, please follow suit. So 15 gallon, I'm going to go ahead and put my zeros first. 15 gallons is $33.75. So now I'm going to have y equals something x. So my change in y over my change in x, my change in y is 33.75 over 15. Sorry, using a calculator again, is 2.25. Before we move on, let's talk about what that means. $2.25. That's telling me 1 gallon. That's telling me my unit rate. That's something we hadn't really talked about in all of these questions. That is telling me what only one of them would cost, which is nice. Okay, so let's look at 20 gallons. So I'm going to do y equals, my gallon is x, so 2.25 times 20. Oh, sorry. I could have done that one in my head. I apologize. And we get $45. How much does it cost for 18 gallons? Gallons, again, is x. So y equals 2.25 times 18. Don't want to try to do that one in my head. Sorry. Some of you are, actually, quite a few of you are really pretty good at doing mental math. So, good for you guys. It's a skill I did not have the pleasure of learning very well growing up. Okay, the cost is 27. So this time we're plugging that into our y because cost was y. 2.25x. To get rid of that 2.25, I'm going to divide both sides by 2.25. Now in previous questions we used the reciprocal because they were fractions, but these aren't fractions. So 27 divided by 2.25, and I get x equals 12. So that would be 12 gallons. All right, last question. Weight on Mars. So we have Mars varies directly. Sorry, I've resorted to abbreviating. With my weight on Earth. They gave me my y and x here in the problem. I'm going to put those in parentheses because it kind of bothered me like that. Okay, so we make a little table here. X and y, where x is Earth, y is Mars. I'll go ahead and put my 0, 0. A science instrument that weighs 130 pounds on Earth, so 130 on Earth, weighs 50 pounds on Mars. I don't know if this is actually true. I plan on looking it up. Maybe I'll pause the video and look it up. If so, it's pretty cool. You can find out how much you weigh on Mars, which is really kind of cool. So let's find our equation. Y equals blank x. Change in y over change in x. Change in y is 50. Change in x is 130. Which is 5/13. So object on Earth, so we're looking at Earth, so we're going to plug that in for x. Weighs 205, so I'm going to do 205 times 5/13. Ooh, I'm going to just go to one decimal. And weighs 78.8 pounds on Mars. An object that weighs blank on Earth weighs 19 pounds. Mars. Mars is my y, so I'm going to plug that into the y. Multiply times the reciprocal. Multiplying times the reciprocal, if you've forgotten. Cancels my 13s, cancels my 5s, leaves me with just that x. 19 times 13/5 is 49.4. All right, so hopefully you don't have any questions. If you do, please send them. Go ahead and tonight's homework is 7.4, so 7.4 homework needs to be done and turned in tonight. For those that have the packets, you can turn it in, send me pictures. Y'all are doing a great job with that. The one that doesn't have the packet, you're welcome to do it on a piece of paper and send me the answers that way. All right, God bless. Have a great day.